All right, guys, welcome. Let's do this. We are doing piecewise functions here. There's going to be a lot of things that they ask you about, so this is kind of like notes on that. And this problem is a fairly common problem. It looks like, let's see, functions defined on the interval, the graph is above. It's 3 line segments and it's a quarter circle, so they're telling you what types of shapes it is, so be aware of that, so that they're lines, and it's a quarter of a circle, so think about it that way. So you take the area of a circle divided by 4 if you ever needed to, and they're giving you the point where the center of the circle is 2, so that's nice. And then they're giving you this f of x equals thing, which is really the, I don't know, it's really saying that the integral is f of x, so the derivative of f of x is, I guess, just g of x. And you could probably just plug in x's to that and get some answers at some point. Just plug in x for the top of that integral and then just integrate. And then remember, integral is area under the curve. So we're looking to find values where we have a critical point. We want to know if it's a local max, a local min, or neither. And we want to make sure we justify our answers. So what's a critical point? Well, a critical point is when the derivative is equal to 0 or the derivative is undefined. So you might notice the derivative is equal to 0 here, and the derivative there. Imagine that's really sharp. That's the derivative is undefined there. So these are critical points. Any of those points that I'm arrowing to right now are critical points. So we're going to need to figure that out for this. And it's saying f, so you look in the red box. That's what we want to find a critical point for. So we need to look at the derivative of f, obviously. So just a real quick reminder, we'll get rid of that for now and see how it goes. So let's get down to it. F has a critical point. That's one thing I want you to notice. So obviously we need to take the derivative of f and set it equal to 0 or equal to undefined. Don't forget about setting it equal to undefined. It's a very typical thing to do on the exam, and it will hurt if you forget. I guess what I'd like to know is, what is f prime of x? That would be nice to know. So we have f of x, but we don't have f prime, so we could just derive what's in the red box, I suppose. So if we look at deriving an integral, what's that all about? Deriving an integral. Yeah, I guess deriving the integral will just give us g of x. So if you think about it, right? And let's look at that for a moment. We have to think about it this way. If we just take the derivative of an integral, we'll get just g of x. This is the second fundamental theorem. So try to be aware that the graph of g is equal to f prime. So now we just need to know when f prime is 0 or undefined, so we really just need to know when this graph is 0 or undefined. So I'm looking at this graph because it is the graph of f prime, and those 3 blue places are where the graph is 0. So those are going to be the critical points, right? Those are going to be the critical points. So those are going to be the critical points for f. So we know that they are negative, 6, 2, and 6. We're just looking for those, and those will be critical points on the other graph. All right, so from here, where do we want to go? Well, we need to be on the interval only until 6, so I'm going to erase this 6. You notice that I just realized that. We don't go all the way including 6. But we just go up to 6. So that's where it ends. All right, so don't include 6 because the interval only went from there to there. And now we want to be here. And we need to figure out what the critical point is, I think. They didn't just ask for the critical numbers. So if they're asking for the critical point, oh no, they just want the x value, so we're actually in okay shape. So now we got to move on to part B. And in part B, they're saying find f of 0 here, it looks like. And f of 0 oh, sorry about that. I'm forgetting that I have to classify these critical points as maxes or mins. So clearly the first point at -6 is a min, since the derivative goes from negative to positive. And you can kind of see it happening here. I circled it in red on the left. If you see the derivative, which is what we're looking at, goes from negative to positive, you know that there's going to be a minimum there. You need to have that red sentence. Now we got to classify point 2, x equals 2. Well, if you think about x equals 2 for a second, what is f prime doing at x equals 2? It looks like, and I'm just kind of going from the left of that green point, it looks like f prime is going from positive to negative. Remember, we're looking at the graph of f prime. So if f prime is going from positive to negative, then 2 is going to be a max. So here's the positive, here's the negative, so it's going up and then down. The regular graph is going up like the top of a roller coaster and then back down. So that's how we justify our answers. That's really what we want to do here. And now let's move on to the next part of this question, which I think is part B. Oh, here we go. So we have find f of 0. So if we're looking to find f of 0, I guess we need to just plug into that red box. So you see that red box is f of x. We just need to plug 0 into that red box. So if we plug 0 into that red box, they're asking us to integrate from -8 to 0. So we really just need, well, what's the integral? Think about that for a second. How else do we think of the integral? The integral is the area under the curve. So we need the area from -8 to 0. So f of 0 equals, and we're going to plug in, the integral from -8 to 0 of g of t dt. Now we have g of t dt up above, so we can look at g of t and go ahead and do some plugging in there, and things will be awesome. So we need to find the area from -8 to 0, so I think we're going to need to break it into shapes that we understand. Remember that the area under the curve, you want to make the shapes that are from the graph to the x-axis. So when we're coloring that in, we want to look at shapes that are against the x-axis when we're doing this. So you can always pause the video and give this a shot. I'm going to try it in just a moment here. So I'm going ahead to find the area here and here. I've made a mistake here, though. I'm noticing that there's a mistake here because I shouldn't draw that area in there. That green area is correct. That red area is not right. So be careful of that. Don't try to find the area that's in the red there. Do try to find the green area. That's all good. And then we're going to want to find that green triangle to the far left. I haven't drawn that in yet, but that's what we're looking for. So try to find the green area. Don't try to find the red area, and hopefully you can understand why that is. We got an area of a triangle, an area of a circle. Looks like an area of a rectangle basically going on here. So I'm going to do pi r squared. The radius of that circle is 4. This is the area we really want, that red area there. So just break it into shapes, okay? I have 2 check marks on a rectangle and on a circle. Those 2 triangles, when you find the area, will cancel each other out because that's a negative area in red and that's a positive area in green, and so they're going to just be an area of 0. So really all you need is the area of that quarter of a circle and the area of that rectangle. Don't forget that it's a quarter of a circle, so that area of that quarter of a circle is the area of the circle, 16 pi divided by 4. So that's where we're at here. So our answer is 4 pi plus 8. So now I think we're ready to move on to C, hopefully. And that's a limit problem, and it's been a while since we've done some limits, but x is going to -4. First thing I always do with limits is I just straight up plug in, and I see how that goes. And if I plug in to the integral, if I plug in -4, to the top and the bottom, I get 0 on the bottom, and on the top I have f of negative 4. I can go back to that red box on the left here and plug in negative 4 to that. But I know that that integral right there is what I'm looking at here is going to be 0, because it has a negative and a positive area of that triangle. So it's going to be 0 over 0, and that means we can't really get the limit. We have an issue. So now we have to figure out something good, something smart to do to this problem so that we can get the limit. Now when you have a 0 over 0, you can always use L'Hopital's rule, which is to take the derivative of the top and the derivative of the bottom separately. Do not use the quotient rule, but take the derivative of the top and the derivative of the bottom separately. So the derivative of the top is just f prime of x, and the derivative of the bottom is going to be 2x plus 4. It's still going to be a limit problem, so you'll notice I'm writing the limit here, but we're just taking the limit of now taking the derivative of the top and taking the derivative of the bottom. Don't forget that you have to have a 0 over 0 or an infinity over infinity to use L'Hopital's rule. But now that it's the end of the year, you could really use L'Hopital's a lot. You can like sneak it in there quite a bit. So that's a good thing. So now we're just trying to find that blue limit, okay? So we look at that blue limit, and I put a red circle over here on this f prime of x to the far left here. F prime of x is g. So I really just need to go to negative 4 and find out what the value is there of that graph. F prime of x is g. So I just need g of negative 4, which is 2. And then the bottom is going to be, I think, negative 4. So you can probably just do that arithmetic out, right? So you have negative 8 plus 4. So that all comes out to negative 1/2, okay? So when you're looking at that graph, you're just getting the y value for 2 and then negative 4 on the bottom. Now moving on to D here. Let's just cruise right through because the video's going kind of long, I think. So let's take the derivative of this. Well, that's going to be quotient rule. Derivative of the top times the bottom, so you see that, minus derivative of the bottom times the top as is. Leave it alone. All over the bottom squared. So that's the derivative of h, and now we just need to plug 1 into that and see if we can figure out what all these things are. So we're going to replace all these x's with 1 and see what happens. There might be some work involved, obviously, but this is our last part. So we have h prime of 1 equals g prime of 1, and then we can plug into that other one, x squared plus 1. That's going to be just 2, minus 2, and then g of 1. And then the bottom of the fraction, I think, will just be 4. So not too bad. You can always... Alright, so we're going to cut this here. I don't know if this audio will show up on the video, but unfortunately I didn't explain the problem there. The video was going too long, and you just needed to try it on your own. So we'll wrap it up there. Good luck with that last problem. See you later.